Good evening, students. So let's start with writing part 1. That is question 1 will be from the pages 10, 11, 12. And the learning outcome that's expected to be obtained is develop a tool, equation or sketch to obtain the resultant electric force exerted on a powering charge by a nearby system of charges using superposition principle. So to understand superposition principle, we will be using, of course, Coulomb's law. You will be familiar with that. So you can just pause and read. So you need to know the values that you will substitute. For those of you who are very familiar, this might be easy. You can skip, but the others, take a look at what's a formula, what's a unit. So it's electrostatic force. So force is kq1 q2 over r square, and the unit should be Newton. And k value is this, and k is related to epsilon naught, that is permittivity of free space, with k as such. So k is 1 by 4 pi epsilon naught. Okay, so that's the starting of this unit, and there's a concept check question as well, so you can go through those. So it says you place two charges a distance r apart, and this this could come not only in force or electric field or electric potential, any they could ask, but just read it carefully. You place two charges, so there are two charges, and then you double each charge, so the charge value is doubled. So if you take q1, it becomes 2 times q1, so q2 becomes 2 times q2. So both charges are doubled, all right? And then what else is, other change is there, double the distance between the two charges. So if initial distance was r12, now it is 2 times r12. Okay, so those are the changes. So this is like before, and this is like after. And they ask you what change does happen to the force. So what you do, the normal formula, the first formula if you write, so before if you write F is K Q1 Q2 over R12 squared. So that's the basic formula. Now after the change, so the new F new is, so you substitute all these values. So you have K, Q1 becomes 2Q1, Q2 becomes 2 times Q2, and 2R12. Here you have to be careful, it's the whole square. Okay, that's where the catch is. So because you might tend to, okay, this is doubling, that's doubling, and you might say, okay, the force also will double, but you will notice it's not that case. So here it becomes K times, so the 2 times 2 will become 4, so 4 Q1 Q2 over, so 2 square will give you 4 R12 square. So you can cancel out the common terms. So 4 and 4 are common, get cancelled. So you notice you end up with K Q1 Q2 over R12 square. So this is F new. So if you compare this new force with the original one, do you see any change? It's the same as it is, because the changes in the charges and the change in the distance, and when you substitute in the formula, does not make any difference in the electrostatic force. Hence the new force also will be the same. So option E is the right answer, right? So this is application of Coulomb's law. Since it's in that page, I have just explained that. Now coming to superposition principle. Superposition principle is nothing but you are adding all the forces that's acting on a particular charge by the forces that is exerted on it by the nearby charges. For example, if you take Q3, what are the forces acting on Q3 by Q1? Now this you must be familiar with when you write F1 on 3, okay, which if it is F2 on 3, and what is the difference between F13 and F31? Okay, F31, actually the magnitude will be the same, means the value will be the same, but the direction will be opposite. So F13 will be negative of F31. You will understand what I'm trying to say. Let's see in this case, in this example, you have three charges. So Q1, if you take, the force exerted by Q1 on Q3 will be, since this is positive, this is negative, so it's going to be attractive force. So the positive charge will try to pull towards itself, right? So Q1's force on Q3 will be to the left. How about Q3? Q3 will be again acting as an attractive force, but it will try to pull Q1 towards itself. So it will be in the opposite direction. So this is F13. This is the force by 3 on 1. Okay, these two are acting in the opposite directions. So hence you have the negative sign. So you have to be careful in writing the correct notations while you are solving questions, because that will be helpful as well. Okay, now let's see an example. Example 1.2. Okay, let's solve this concept check question. It says there are three charges arranged on a straight line in the figure. What's the direction of the electrostatic force on the middle charge? So there will be two forces acting on the middle charge. Now this is negative Q and this is positive Q. So which direction will the negative Q, this also is positive, this also is positive. So the negative Q will be trying to attract it towards itself, right? So the force is acting towards the left by this charge. How about plus Q? This also will try to repel it away. It will try to push it away because it is like charge. So this force also will be acting on the left. So if you take it together, you have the resultant force onto the left side. So B will be the right option. Okay, so this you might expect it in a multiple choice question, because there are questions based on this mentioned in multiple choice as well. Coming to this question here, there is a difference. You have twice the charge on the left side. Alright, if you take concept check 1.7, this is a little bit, you have to think before you apply. So I've taken it as three charges. So one is negative 2Q and the other one is positive Q, positive Q. So say the charges are given as, this is negative 2Q, this is Q itself, and this is plus Q. Now they ask you what's the resultant or the net electrostatic force acting on the right charge. So you are supposed to find right charge is this one, which is Q2. So in our diagram, we have taken it as Q2. So what will be the force exerted? What direction will the force act on? So if I take force 3 on 2, what will be the direction? It will be attracting it towards itself, right? It is negative and positive. So your force direction, this is going to be to the left, and by 1 on 2 will be pushing it away, so it will be to the right. So we have the directions opposite, but we do not know the magnitude. So here the magnitude is not the same like previous question. Previous question the magnitude was same because it was at the same distance. If you notice here, the middle charge, so it was at the same distance from each of the charge, and we saw that both charges were acting, both forces were acting to the left. Here, of course, direction is the same, but we need to think about the magnitude because the distance is not the same from Q2 to Q1 and Q2 to Q3. So, if I take the values, so K times Q3, Q2 over the distance from 3 to 2. So, which is that? Choose a different color. Okay. So, Q3 is negative 2Q. So, I put that negative 2Q. Q2 is Q itself, positive Q over. Now the distance. So if you take the distance from Q1 to Q2 as R, what about the distance of Q2 to Q3? It should be 2 times R because it's twice the distance. So it is, sorry, this should be square. So 2R the whole square, right? So let's just simplify the formula and keep it. So it's K 2 times k q square over this 2 square will become 4 r square. Okay. Now I have not included the negative sign because we have already included it in the direction. Right? We have taken it to the left, so you don't have to repeat it again here. So it is kq square over 2r square you will get. How? Because you can cancel out 2 and 4 will cancel for 2. So you have kq square over r square is for F32. Okay. Now how about F12? It is just k q1 q2 over the distance is r, just r square. And since q1 and q2 are just q itself, so k q square over r square you get. Now see which one will be bigger. This F12 will be bigger or F32 will be bigger. F32 is half the time, 1 over 2 times this force. So the relation is like F12 will be equal to double, 2 times this charge or this force, sorry, 2 times this force. So if you look at the diagram, which is greater? The force acting to the right is greater. So this force is double that of F32. So this is double. So if you take the net force, if you take the difference, so finally your net force F net will be acting to the right. Okay. So you can put in values and check. If you're not very sure, you can, since Q are all equal, you can just take it as 1 and then substitute and check. Okay. So that way also will be easier for you if you're not comfortable in taking it with the formula. Okay, that is concepts check 1.7. Now example question, it's about what's the magnitude of the electrostatic force that the 2 protons inside the nucleus of a helium atom. This actually they have not given some values here, the distance between the 2 protons, so we need to know that, just the direct substitution of the formula. So k q1 q2 over r square. So all these, the charges of proton and electron will be given in the question for our data sheet. So 9 times 10 to the power of 9 times 1.6 times 10 to the power of negative 19. So both are same, so we'll have to repeat it once again. 1.6 times 10 to the power of negative 19 over the distance between 2 proton is 2 times 10 to the power of negative 15 the whole square. So your answer, you should be put the value and you get 58 Newton. Actually, along with this, there is a second part question, you can refer to the textbook, which is what is the magnitude of the electrostatic force between a gold nucleus and an electron with radius is given as 4.88 10 to the power of negative 12. So what does this mean? So what is the what are the 2 charges here? See, in the previous question it's very clear, there are 2 protons, so you just have to find the force between them. It's a direct substitution of the formula, but here it's slightly different. You have a nucleus and then you have the electron that is revolving around it, and they are asking you to find the nucleus of the gold atom. So what is the force exerted between the 2? So for finding the force, what do we need? We need the charge on the first particle, the charge on the second particle, and the distance between the 2, right? So K is already known. So K, now Q1, if you take it as electron, as this as Q1, and the nucleus as Q2, we know the charge on electron is, so I'll substitute for K first. So Q1's charge is electron's charge, which is 1.6 times 10 to the power of negative 19. But how about the nucleus? What is the charge here? How many charged particles are inside? We know that nucleus will contain protons. Which are the charged particles? Depending on the type of the material, type of the element, you need to find out how many protons are inside. Okay, since it's gold has an atomic number of 79. So that shows there will be 79 protons inside. Okay, so electron, it is one revolving around electron, one electron and 79 protons. So what will be the charge of Q2? The total charge on Q2 will be 79 times 1.6 times 10 to the power of negative 19. Okay, so that should be substituted for Q2. 79 times 1.6 times 10 to the power of negative 19 over the distance between them is given there, 4.88 times 10 to the power of negative 12 square, and you should be getting an answer of 63 times 10 to the power of negative 4 Newton. Alright, so just be, these questions are all not very complicated or difficult, just that little bit of details you need to think and apply. What's the charge on each one of them? So when they say a nucleus, then you should think about, okay, what are the types of charged particles inside the nucleus? How many numbers will be there? So do I know the charge of a proton? Then you multiply with the number, you will get the charge. Okay, so that's about the first couple of types of questions. That's using Coulomb's law. So we calculated the forces existing between two charges and also the direction, how to identify the direction by using the concept, that is concept check. Okay, now this is a different type of question where you have to approach it totally in a different way. What is this? Equilibrium position. So equilibrium position meaning the object is either at rest or it will be with uniform motion. Right? You have learnt it before in Newton's law. And what does that imply? The net force will be equal to 0. Or you can say the forces will be balanced. So if you have a force on the particle acting towards the right, there should be an equal and opposite force onto the left that balances it. Right? If you have a force acting down, there should be an equal and opposite force acting up that should be balanced. Even if you have it here in this direction, there should be an equal and opposite force in the opposite direction, so that all the forces are balanced in that particular object to maintain it in an equilibrium position. Okay, that's about the concept. Now what do they ask you to find? Where should be a third charge placed to be so that it is in equilibrium? Okay, so it's a little bit of thinking to do. So this picture may not be given in the question. So this is part of the solution already. Okay, so you have two charged particles are placed as shown in the figure, and the first charge is at the origin, means so the distance of the first charge can be taken as 0. It starts from 0, and there is a second charge. It's your choice to choose. You can take the total distance as x. So it's at a distance x here. And where will you place the third charge? That's a very important question, because in some situations we'll keep it outside, some situations we'll keep it inside. Here we keep it inside here because the two forces should be acting opposite to each other for it to be balanced. Alright, so we are keeping, where should the third charge? Okay, the third one is placed in the middle so that the attractive force by Q1 and the attractive force by Q2 will be cancelling each other out. So if F net should be equal to 0, F13, that is the force acted on Q3 by F1, it's towards the left. Why? Because it will be attractive force, should be equal to F23. So this will be a basic formula. Okay, so equilibrium position, if you get, first you think, if you place in the middle, will the forces be acting on the opposite direction? If it is acting on the same direction, you can't keep it here, you'll have to keep outside the two charges, right? Okay, so F13 is F23, then you will just have to expand the formula K Q1 Q3 over R13 square. This will be equal to K Q2 Q3 over R23 square. So if you take this entire distance as sorry, instead of taking this as x, actually, because x is other question, right? Where should, so you can take from this as x, and x2 is 0.4 meter. So this whole distance, this is 0.42 already given, 0.4. So what will be the distance from 2 to 3? This part will be 0.4 minus x. Okay, so x is our question. Where should this q3 be placed? That's the unknown. This is total distance 0.4. That's q2 from q1. We don't need that in the formula because 1 and 2 are not in the formula. We need to know the distance from 2 to 3, which is total distance minus x. Now the rest is like you have to use your math skill to complete the solution. So q1 q3 is equal to k q2 q3. So you can cancel out the common terms. Before that, let me put in r1 3 distance, 1 2 3, the distance is x, so it's x square here, and here this is the next distance 0.4 minus x the whole square, right? And then you cancel out the common terms. K is constant, common, you can cancel. q3 also can be cancelled. See, the formula simplifies to what? q1 times 0.4 minus x the whole square will be equal to q2 times x square. Now you can shift solve in your calculator, but be careful to delete the previous the values or formulas that you have given, otherwise it will affect your answer. So you can take square root on both sides. That is like if you're trying to solve it manually, taking square root, this will become square root of q1, and this becomes 0.4 minus x will be equal to square root of q2 times x. You can gather the x terms, substitute the values, and get the final answer. You should be getting for this 0.16 meters. X should be 0.16 meter. So what's the difference in this question? As I explained earlier, 2 points to remember. If you have like charges, a third charge will be in the middle. Okay. If it's unlike charge, positive and negative, the third charge should be placed outside, because then you will have the forces at opposite direction to each other, which will cancel. If you place it in the middle, the net force will not be zero for that case. Alright, so keep that in mind and place it correctly. Now the next question is this. This requires a little bit of thinking. It's a little complicated question, I would say. So, but the previous questions, it's like from simple to this equilibrium position should be a medium level, and this would be a challenging question. You can take a minute to read. What are the information given in the question? In the figure, the net electrostatic force acting on charge, see, QA is 0, means QA is in equilibrium position. Okay, previous case it was in a line, so it was easy for you, that's okay. But here, see, it's at a totally different angle it is placed, and they ask you to find the magnitude of the charge Q0. This charge is what you need to find out. Okay, and this is also 1 nanocoulomb, so this is plus 1 nanocoulomb. And look at the distances that is placed. This distance is A. Okay, this distance is also A. But how about this point QA? They say it's at positive, so this is your x displacement, this is your y displacement, right? X and y. So on the x-axis you have double the distance. So if you take it along this is like till here, it is 2a. Similarly, if you take it here, this entire distance is negative 2a, which is in the downward direction, 2a. Okay, so that's a total scenario. So you have like a square where in the middle of the square here you have a charge which is negative let's take that as Q1, and here you have a charge that's Q2, and at this corner you have QA. Here you have the charge Q0. So Q0 is the question you need to find. Q1, Q2, QA are known to you, and you need to identify the forces that is acting on QA and see where it is balanced and equate them. It's a little bit of challenge one, as I said before. So let's see, this Q0 will exert a force, Q0 and QA, if you assume it to be positive. So you will have the force acting on it towards a, like, diagonally outwards, right? So you will have the force. So this is Q0 on QA. What about the direction of force that is exerted by Q1 and Q2? So this we took it as positive. So there is a repulsive force is pushing it away. Q1 is negative. This is also negative. They gave it as -1 and -1. So this will be attractive force. So you will have two forces acting towards this charge Q1 and this charge Q2. So this will be Q1 on A. This will be Q2 on A. Okay, so those are the three forces that are acting on charge QA, because they said that the electrostatic force QA is 0. That means it's in equilibrium position. So we are taking all the possible forces that will be acting on QA. Okay, on QA, by Q0 you have a force, by Q1 you have a force, by Q2 you have a force, and we have drawn it by direction. So we have just drawn the vector diagram. Now our aim is to equate. So we will use the same starting point, F net is 0, and frame a valid equation and try to solve the question. Now, if you take this force as I explained earlier, so you should have a force acting in the middle. So these two forces should be equal, right? So in a line, if you take, so the forces acting on one side should be equal to the forces acting on the other side. So this can be calculated by using the formula. So Q0 A will be equal to K Q times, so we'll keep the same, Q0 QA over R, distance between ROA square. Okay, you can substitute the values and Q0 will be the unknown there. We will leave that for the time being, and then we need to find out Q1A, but Q1A will not be acting along this line, right? It's at an angle. So you'll find the component of Q1A. So Q1A is a component, okay, plus both are acting. Again, Q2A also will have a component. So these two together will be balancing Q0A. I hope this is clear. This is the basics of, or the basic equation. The component of Q1A in this direction plus component of Q2A in this direction should balance Q0A. Okay, so keeping this in mind, so what are the unknowns here? So we need to find Q1A. We need to know this angle. Only then you can find, if you take this as θ1, this as θ2, these two angles should be known for us to find the component, right? Because for component we need angle. Now let's go to the detailed picture of it. Okay, so that's a total picture given, not given in the questions, it's just drawn for you. So what is this distance? This is A. This part is A, and the total is 2 times A. Similarly here it's A and the total is 2A, and so on. So all are labeled for you. Okay, now this is a square, so the diagonal, if you draw the midline, this total line will make an angle. This angle will be 45 degrees. right? And this angle will also be 45 degrees, total is 90, that's fine. So based on this formula, if we need to find theta, our aim is to find theta, okay? But theta plus alpha, alpha is this part, will be equal to 45 degrees. So that's what we know from the situation given, okay? I repeat, so you have this total triangle. If you take this triangle, if you take this entire angle, this whole of this angle is 45 degrees, which is as per the symbols taken, theta plus alpha is 45. But how do I find theta from here? So if I know alpha, I can find theta. So is there a way to find alpha? Yes, because this one is a right angle triangle, right? This is a right angle triangle. So if I draw here, right angle triangle, so you have this base to be A and this part of the triangle to be 2 times A, and this is theta. So we can find tan inverse of opposite side, which is A over 2 times A, right? Opposite over adjacent. That will give you tan inverse 1 upon A will get cancelled. So it's 1 over 2 is like 0.5. That angle gives, so we get alpha to be 26.6. So we can find theta from this equation. Theta will be 45 minus 26.6, which is 18.4 degrees. So we got what we need from this triangle, which is theta is 18.4 degrees. All right. So that is one part of, so we are doing it in stages. So part 1 was to identify the forces acting on QA. Part 2 is to find the unknowns that we need to solve the question. And now we'll go to step 3. Okay, we found this angle. So if according as per my diagram which I drew earlier, if I write F, I'll use that diagram. So here the force on FOA should be equal to F1A. If you take that as component, if you take this as the x direction, this is the x direction, so F1AX plus F2AX, right? So how do I find F1, FOA, F1A, F2A is our next task. Okay, so FOA will be equal to K Q naught QA over ROA squared. So Q naught is given as 1, sorry, QA is 1. So this becomes K times 1 over, now ROA square. So do we know the distance here? They have not given the distance, but this will be square root of, because it's part of this bigger triangle sides are 2A and 2A, so it will be 2A square plus 2A square. So it will be square root of 2A the whole square plus 2A the whole square. And in the formula we already have a square, so that will become, so the square root and square can get cancelled, so this will get cancelled. So what will be the final formula here? 9 times 10 to the power of 9 times Q naught, this I missed out, so Q naught times 10 to the power of negative 9, because this was given as nanocoulomb. I repeat, QA is 1 nanocoulomb, so 1 times 10 to the power of negative 9, and Q naught is our aim to find out, right? So times 1 times 10 to the power of negative 9 times, if you want you can keep it as capital Q as per the question, over, now how do we combine this? 2 square will become 4A square, and this also will become plus 4A square, so which will add up to 8 5a square, right? And this can be simplified. Plus 9 minus 9 will get cancelled. So this will be 9q0 over 8a square. You will get for what? This is FOA. That is, the force acting in this direction is 9q0 over 8a square. Okay, now what is our next aim to find out? These two components, F1a and F2ax. Now since they both are the same, because same charge and the distance r1 is equal to r2 will be the same, so if I find Fa1 I can do it times 2 to get the total force. So Fa1 is how much? This is also 1 nanocoulomb, the other one is also 1 nanocoulomb. So K is 9 times 10 to the power of 9 times 1 times 10 to the power of negative 9 times 1 times 10 to the power of negative 9. And here, what's the distance? This distance will be, one side is, this is A and this is 2A. So R2 will be square root of A square plus 2A the whole square. That's the difference, this distance. So you'll have square root of A square plus 2A the whole square. Okay, and you have the square. So the square and square root will get cancelled. Okay, and even this also will get cancelled. Sorry, this will get cancelled. The negative 9 will remain. This will remain. So here will be 9 times 10 to the power of negative 9 over this will be A square plus 4A square, right? 2 square will become 4A square, so it will be 5A square. Okay, and as I said, even F2ax, sorry, F1a, so F2a also will be the same, which is 9 times 10 to the power of negative 9 over 5a square. So how do we put it in the formula? So 9q0 over 8a square is equal to 2 times 9 times 10 to the power of negative 9 over 5a square times cosine theta is there, because we need to, this equation is, what is the equation? Component in the x direction and component in the x direction. So since both are equal, this will be like 2 times F1a cosine theta. Okay, so we found F1a, that's the answer. So we put 2 times that answer times cosine 18.4 degrees. Now we'll notice again we have common terms we can cancel out, which is 9 will get cancelled. You have a square also will get cancelled, right? And then you bring q0 will be equal to 2 times cosine 18.4 times 10 to the power of negative 9 over 8. Okay, which will give you 3.04 times 10 to the power of negative 9 coulomb. That's the final answer. So it might look confusing. Only thing is that the way that the charges are placed are in a different direction. So if you just tilt it and see, if you assume this to be the x direction, you need to, it's like a normal line. You have a force on the right side and you have two forces acting like this at an angle theta. Okay, this is like your q0a, this is q2a, and this is q1a. Okay, so we are taking the x components of q1a, q2a, adding them up because in the same direction, and equating it to q0a, and finding the unknowns by using a and then substituting. I know this is a bit, as I told you earlier, it's a bit challenging one. So watch this and then take a screenshot of the question. Try to solve it on your own 1 or 2 times. You will get it right. All the best, students.